Hi guys, today I would like to give more details regarding the MV switchgear type CV and CCV, which are common configuration in PCS MV station. I will introduce the connection method between the PCS and grid and some common questions from customers. Here is the partial single line diagram of PCS MV stations, medium voltage switchgears, step-up transformer, and connect to PCS. 3 cabinets inside here, 2 C cabinets, and 1 V cabinet. Vacuum circuit breaker here is inside V cabinet and has already connected to a disconnector and a step-up transformer internally. Load switch here is inside C cabinet, so you can choose one C cabinet connect to the grid and another to connect to next MV stations. Because the two C cabinets, the configurations are the same. This picture shows the typical connection ways of CCV. One PCS MV station includes 3 MV switchgears, C cabinet to connect to grid side, and another C cabinet to connect to next MV switchgears or PCS MV station is the same, and the V cabinet, all the cables or bus bar has already connected internally before shipment. Now you understand how CCV connects. Normally, CCV is applicable to the situation which the quantities of the grid connection points are less than that of the PCS MV station. Let's say one grid connection points with 3 PCS MV stations. Only one PCS MV station can connect directly to the grid. So CCV is required in these scenarios. Regarding the CV, you can see the diagram here, only one C cabinet and one V cabinet. So CCV remove one C cabinet, that's CV. C cabinet will directly connect to the grid. That means only one PCS MV station can connect to the grid connection points respectively here. So 3 PCS MV station and connect to 3 grid connection points respectively. Now you have already understand the difference between the CV and CCV. I will summarize some common questions and answers. So first, what's the function of load switch, vacuum circuit breaker, and disconnector? Load switch inside C cabinet. Load switch has a little arc extinguishing capabilities. It can be cut off when a normal current existing, but cannot cut off when a short circuit happens. So load switch cannot used as a system protection devices. Vacuum circuit breaker inside V cabinet. This device has a powerful arc extinguishing function. It can cut off the normal current and short circuit current. It is the main protective device of the system. Next, disconnector inside V cabinet. Without arc extinguishing capability, we cannot operate it. When current existing, disconnector just provide a visible physical disconnection points during system maintenance, ensure the person's safety. To conclude, only vacuum circuit breaker can serve as the protection devices when a short circuit occurs. This slide is very important because it will relate to the short circuit impact range between the CV and CCV. I will show you in the next slide. So next, how to choose a CV and CCV configuration. Regarding CCV, when quantities of the PCS MV station more than or equal to quantities of grid connection points, we will choose CCV. So when the quantity of the PCS MV station less than or equal to quantities of the grid connection points, then we choose the CV. However, a CCV can be used as a CV by leaving one C cabinet unused, but this is not cost effective. Next question, how many CCV can be connected in a grid connection points? So let's calculate the maximum current, consider the derating curve of temperature and altitude. Let's say grid voltage is 20 kilovolts. Single units for PCS MV station is 5 megawatt. Rated current of medium voltage switchgear is 630 amps. We ignore the efficiency loss. So the rated current of a single 5 megawatt system in 20 kilovolt side is 5 megawatt divide 20 kilovolt divide square root 3. The answer is 144 amps. So the rated current of single switchgear 630 amps divide 144, that is 4 units. So the result is in one grid connection points, we can connect up to 4 CCV units. But please take derating curve of temperature and altitude into consideration. Normally, some supplier will be more conservative. They may consider the low limit value of grid voltage and reserve more margin. This calculation results is for reference only. Please compare it with your suppliers. So you can see the diagram for easy understanding. So there is four sets of PCS MV stations, and only one PCS MV station will connect directly to the grid. So you can see the current flow, let's say discharging, charging from the grid here, and to next, and to the last. Okay. So the next question. Short circuit fault impact. I think this is a most different part between CV and CCV. So first, we can see the CV configurations. If a short circuit fault happened in the CV AC side, the worst case will cause the vacuum circuit breaker in the V cabinet tripping, or the circuit breaker on the grid side tripping. The impact range is the same in both cases. The PCS MV station where the short circuit occurred will be in faulty, while other equipment will remain unaffected. So of novel, and novel. While the CCV is more complicated, two situations will lead to different outcomes. So Here is a PCS MV station here, and 3 cabinets CCV. And this is the nest medium voltage switchgears, the same configuration CCV. Yes, and this C cabinet connect to the grid. Okay, so this C cabinet connect to the nest MV switchgears. So when a short circuit fault occurs downstream of the vacuum circuit breaker in V cabinet, after the point A here, the blue line, the most severe outcome is that the vacuum circuit breaker QF2 here tripping. But other equipment remain unaffected, so this MV station will not be influenced. But when a short circuit fault occurs upstream of the vacuum circuit breaker QF2, the B points marked by red line, let's say in the bus bar of the C cabinet, V cabinet, or inside the C cabinet. Because the load switch here in the C cabinet is unable to cut off the short circuit current, so the grid side circuit QF1, this circuit breaker QF1 will trip to protect the whole systems in these scenarios, causing all the equipment, these two equipment, in faulty. It is the same results when the short circuit point A and point B in any other medium voltage switchgears, for example, here, it's the same. It's the same because the grid breakers is the only protective device in these scenarios. However, the possibility of a short circuit occurring at the load switch, or on the grid side AC bus bar is extremely low. Point B, red line. So don't worry about it. So this is all the introduction for today's video. Thanks for watching. See you in the next video. Bye bye.